Hi everyone, welcome to my coding channel, Coding Learner. So today we learn how to create a queue using stack. So let's move forward. So there's a two approach. The first approach is we create a two stack, and by using these two stack, we are dequeue the element from the stacks. So how we enqueue the elements in a queue. So what we are doing, we just push the element in the stack one, and what if we want to dequeue the front of our queue. So basically we pop each element present in the first stack and push it into the second stack and then pop the element from the stack. Just delete the top element from the stack too, and again we push all the elements in the first stack. So this is how the first approach will work. Let's move forward for the second approach. So what we are doing, we are using a recursively popped. So in the second approach, if we check if our stack is empty or not, is the stack is empty, then we simply return -1. It contain the We are talking about the dequeue operation. We are not talking about the enqueue because the enqueue operation is so easy and similar. We just push the element in the stack, and here in this approach too, we just use one stack. So if our stack is empty, then return -1, and then we recursively calling the function and we are placed at the last element of our stack, and then we find that our stack is empty. It means that we are at the last element of our stack. We are simply save this element or return in the function. We are recursively popping everything from the stack and store in the popped element item. And in the res or x variable, we push the each remaining elements from the variable to the stack. So this is how the approach 2 will work. So the approach 1 is easy, but we are learn how the approach 2 will work. So initially I created an int pop one function. It means that we dequeue the element from the stack. So we are expecting that we want to delete the element. It means that we delete the 12. So we are not using the second stack. We simply check if our stack is empty. Here s1 dot empty is false, then we just come forward for the next step where we say that we save the top element of the stack in the x variable, and we just pop the top. So this is how the top will be deleted. And then we check if our s1 is empty. No, it is not empty because we're having a two elements in our stack. We just simply move forward for this line. It says that int item is equals to pop. We are calling the function again. So when we are call the function itself, then what we are doing, now we again check. We are came at this position. Now we again check s1 is empty. No, it is not empty. Let's move forward. We save the top element of the stack in the x variable and then just pop it out. So this is how the 13 will be deleted from here. And we again check if our s1 is empty. No, it is not empty. Let's move forward. It again calls the int item pop function. Recursively calling will be continue. And again we are at this position. We check if our s1 is empty is true, then just return -1. It is not empty right now. Then we save the top element in the x and then just pop it out from the stack. And again it's checked that if s1 is empty, yes it is empty. Now we just return x. So here we return the value 12. So the previous item will be 12 and it's remain 12, and then we push the x variable here 13. So it push it back to the stack and just simply return the item which values is 12. So we find that all the recursively calling will be done at last, and it returns simply the item which is 12, and it push the 14 in the stacks. So this is how the top one function will be completed, and it simply return the value which we need to be deleted. And now new stack will be look like that. So the aim of our dequeue will be done because we delete the front element from the stack. Let's move forward for the implementation. So now we implement our approach 1 for making the queue using a two stacks. So in the public, I created a class name as queue, and there is a file over here which we need to be included. There is a header file stack. So we simply use all the operation of the stack, just calling. It is the inbuilt function for the stack. So in the public section, we create the stack. To define the stack, we simply write stack, and it is a int type stack. And let's take s1 as the name of the stack, and it is the stack 2, which is as well as int type, and let's take it as 2. And what we are doing, we just create a amq function which takes the value, and we just simply push it to the stack 1. And now we create our void and dequeue function, and in our void dequeue function, we first stack if our s1 dot empty function is true, as well as s2 dot empty function is true, then we just simply return. We just simply return. And if it is not, then what we are doing, we create a while loop until and unless our s1 dot is empty is true. Until and unless our s1 dot empty is false. So let's move. We place our s2 dot push, and here we get s1 dot pop. So it takes the top element from the stack 1, and we push that top element to the second stack, and just simply s1 dot pop, we delete the top of our stack. So when all the elements are placed at the in the stack second, then we just pop the top element which is present at the top of our second stack, just s1 dot pop. What if we return it inside? Here we take -1, and we just return the top element of the stack. Return top element of the stack. Let's take the int well. First we save the top element to the well, and then simply s2 dot pop, we delete the top element and we just return the value. So this is how the dequeue function of our class q will perform. Let's move forward. Let's put the elements in the stack. Let's take 12, 2 dot, and q, let's take 13, and q1 dot, and q will be 14. So now we are calling the pop operation or the dequeue operation of q class, and we expecting that it gives you the 12 element, because it is the first element which we inserted in the queue or a stack. Just see our statement over here again, dot dequeue function, and again, so we are expecting that here we get 12 and here we get 13. So let's see. And so this is how we get the 12 at the first output, and then we get the 13. So this is how the first approach will work. Let's move forward for the second approach. So it's time for the second approach. There is a same function for the enqueue. Let's move forward for the dequeue function. So we are calling the recursively calling. So first we check, we just using the stack 1, we didn't need the stack 2. First we check s1 dot empty function is true. If it is true, then just return -1. Just return -1. And if it is not, then what we are creating, we creating the int x variable which store the value of the top of the stack, and it simply pop the top element of the stack. And we again check if our s1 dot empty function is true, then we just simply return x. We just simply return x. And then if it is not, then we create the int type item, and then we call the dequeue function again. Dequeue function again for recursively calling, and then we push the x variable, and then just return item. So it's done. Let's run. So you can see that it's works similar to the first approach, but the time complexity is much better than if we compare the second approach to this first approach. We are using just one stack over here, and in the first approach we use the two stack. Somewhere it affects the time complexity or space complexity. So it is the simplest way for the DQ operation of queue using two stack. So that's it. For more videos, please like, share and subscribe.